Thank you, everyone. So I'm very excited tonight, to talk about what's the art of finding extraterrestrial life in our galaxy, and also answer the question, will they call myself on my cell phone? Will I pick up my cell phone one day and hear alien languages and I couldn't understand? So the short answers for that question is no, because our cell phones work in a cell tower network which transmits signal in a very short distance, and it is really not designed on purpose not to transmit signal to outer space, otherwise those companies are losing money. So, but I'm going to talk about what's the art of finding extraterrestrial life in detail. So when we think about these problems or these issues, we always start with these simple questions. Are we alone? Are we alone in this enormous, really big universe? And are we really the only life civilization out there alone in the universe? So in this picture, this is a picture of a Hubble Ultradeep field, which individual object here you're looking at is a galaxy which contains hundreds of billions of stars. So this picture itself you're looking at actually contains probably more than 1,000 billion stars, and this is only a very tiny patch of sky. So imagine there are countless stars, even planets out there to discover, and this is provided a huge sample in our universe. And if we look at around our galaxies, these are the planets that researchers have been found in our solar neighborhood in our galaxy. And you can see there are a wide variety of different planetary systems. There are big planets orbiting around a star in very close distance, or there are multi-planet in one planetary system. So given the huge diversity of planetary system we have found already, and the enormous countless stars out there in our universe, the chance that there's no life out there seems a little bit impossible. So if we take a step back and we just say, okay, if there's a life out there, if we're not alone, is it possible for us to reach out to our neighbor? Is it possible to hear about other civilization? Is it possible for those alien invasion that we see in Hollywood movie? And so I believe maybe all of us have think about these questions sometime in the past. So Dr. Frank Drake, who was an astronomer in National Radio Astronomy Observatory, he developed this sort of method to think about this problem in the 60s, and which also known as Drake equation. It's basically try to estimate the number of reachable civilization out there. He is sort of thinking about this problem in terms of whether we can detect signal from other civilization, whether we can listen their signal to identify the signal from other nature phenomenon. So on the left-hand side here, that's a capital N, that's a number of reachable civilization, and it can be parameterized in these following 7 parameters I'm going to introduce later. So in general, we can roughly put these 7 parameters in 2 categories. One is the 3 of them we have some clue, like lots of astronomers are working really hard every day, try to figure out what's the processes of star and planet formation. And then there's these 4 parameters that we have little to no clue. Like this is really a guess, or everyone can come up with some theory, and their number can be off by several magnitudes. So let's start with the terms I would like to call as astrophysical terms. And it really starts from, so think about where I try to estimating what's a civilization out there. And like for instance, for example, our Earth, we're orbiting around a star, so we have to start from a star. So the first parameter is actually the average rate of star formation per year in our galaxy. And this number has been revised every day and maybe every year, every second. So, but I mean, to be approximately, this number is about 2 to 5 stars per year. And if we try to include those lower mass stars, this number can be as high as maybe 20 stars per year. Then among those stars, what's the fraction of those stars that actually have planet? And so this is the a plot showing here. It's a cumulative planet count per star for the planets between Mars size here and to Neptune size. So you can see those accumulated counts approach to 1. That means that we can probably find 1 planet falling in this range of size with a given period. So we can be, right now I think researchers have found that modestly we can say most of the star has at least 1 planet. But are those planets actually be able to support life? So the next factor is whether those planets actually be able to, is suitable for the life emergence. Like for our Earth here, we are in the right distance from the sun so that we don't get too hot or too cold. And so we can have a liquid water, which is one of the important factor that people try to think about this issue. So this zone, like color in this light blue shade here, is people often call it habitable zone, also called as Goldilocks zone. And imagine if you have a star that have a lower mass, emit less radiation other than our sun, this zone could be much closer to the star. It could be as close as Mercury orbit. So the most recent number I can find by digging through those research papers, for a given star, the chances that you can find a planet that is in a habitable zone is about 20%. So let's just put a 0.2 here for this moment. And here comes the terms that we really don't know how to estimate, or there's a huge debate that we can talk for days and weeks. The first one is, okay, so we have a planet that is suitable for life. What's the chance that that planet actually have a life as an outcome? And that related to one of the biggest questions, that is, what creates life? What makes life possible? So we all know that our human body mostly consists of these 3 fundamental elements: carbon, hydrogen, and oxygen, which we also found in several astronomical sources. We detect those signals all the time. But somehow on our Earth, those elements went through some mystery processes that we don't know, we don't fully figure out yet. Then here comes the life. Any forms of life, right? You don't have to be a human. So if we take our Earth as an example, it seems like there's a suitable condition, there's a suitable atmosphere, and you give the time for that environment to evolve, to randomly evolve, we can probably say then there might be a life emerge somewhere along the line. So we can say, okay, probably 1, but we are not sure. Then here comes the next factor, which is when you have a life, whether it will be intelligent life. So the intelligent life defined here is actually the ability of using tool. So we have a lot of forms of life species exist or exist before on the Earth, but not all of them has the ability of using tool to develop this advanced technology that now that we're using. So if we are being very optimistic, like say the life will form, will evolve, will increase its complexity as the time goes by, eventually in the end it could evolve to the complexity, complicated enough to develop the ability of using tools. Then this number can be as close as 1, but it could be very small as well. Like imagine like maybe like few 100,000 years before in the Earth's history, there's no one knowing how to use a tool. But let's just be very optimistic. Let's say, okay, it's close to 1. Good. And so here comes a very interesting factor, that is, are those intelligent life who will develop interstellar communication? And there's a several questions we have to ask ourselves for this factor. It's not only the technological aspect of that whether we are able to develop those technologies to transmit, is whether the communication around is, like, say, if we're using our cell phone, we're not going to do anything like interstellar communication. Or those civilizations out there might block their signal from other planets on purpose. They don't want to be found. They feel like it's unsafe to be found. It's unsafe to expose themselves to others. And then also the form of communication. Maybe they are communicating already to us, but with a form that we cannot distinguish from the signal we're detecting. Or they might be using mind control that we just don't figure out. And so the original estimate by Frank Drake is about 0.1 to 0.2, but I really don't think we have any clue of this one. I mean, this number could be as high as 1 or as low as very, very, very tiny number. So here's what we have right now. And then what's left is this last factor. That's the length of such a civilization that can perform interstellar communication and can continue doing the interstellar communication in the length. So the problem here is how long the intelligent civilization will last. Whether a civilization evolved to enough advanced technology, will they find peace with each other, or will they like develop some self-destruction weapons and just going to destroy themselves in very short time? And if we look back to ourselves, what will be the future of humankind? Like, we are the only civilization we have known so far. So predicting this number is actually predicting what's the future of the humankind. Where human history could be last for like 1,000 years, 1,000,000 years, or even longer than that. So if we ever detect any signal from other civilization out there, we're actually, combined with other factor we just estimated, we actually have some probe into try to constrain this number. We actually are able to see whether this number is big or small by using some statistical mechanism. And so as SETI astronomer Joel Tarter once said, SETI is the archaeology of the future. By doing the search of extraterrestrial intelligence, we might be able to sort of reveal our future as a humankind civilization. So that's the Drake equation we have right now. And the purpose of the Drake equation is not actually, it is not an equation. It's not an equation you solve for your math class. You try to get a correct answer, that a number out of it. It's more like a math or a path for you to think about this problem, to divide the unknowns from each other, to figure out what's the relation between the unknowns to the other unknowns, and to dedicate ourselves to figure out the things individually. And in the end, I want to conclude with this cute little baby that yeah, it's really fun to watch. So I think it's a quote from Arthur Clarke that any sufficient advanced technology is indistinguishable from magic. That means that even though we detect so many weird signals all the day, we try to, it's really easy to just say, oh, that's something we don't know, or that's magic, or that's signal from extraterrestrial civilization. Although we cannot rule out those options, but I think we have to stay very neutral when we encounter those problems, and we have to ask ourselves what's the logical way behind that, and we have to make sure we are not too inclined to certain options when viewing the issue of try to find extraterrestrial life out there. Thank you.
Okay, thank you, Star Maker. And so we have some time for questions.
I'll let you comment on this if you could. I understand that the way that extraterrestrial life solve problems gets here to say hi, then they don't even come here at all because they've already solved all the problems.
So just make sure I understand the question. Is the question
It's not a question, but...
Yeah, is that a question? Okay, sorry.
Comment?
Well, I think...
Yeah.
Well, yeah, if any aliens have visited us already, then... well, I mean, there's a wild guess. I mean, that means that maybe we already sort of a world that already have an alien sort of ingredient in there, right? So, but I think as the humankind or every species on Earth evolved through this history together. So, I think it's really hard to pick out those like sort of foreign ingredient from our society already. But that could be true. Like there could be some people already or some other entity already visited us in the past, but we just don't know.
I'd like to remind everyone to silence your cell phones, please. We have a question right there.
Do you know if there's any research that's been done on the time variedness of like the first three constants? I assume they're not fixed.
Yeah. So the question is about the research on the first three numbers. So the first one is star formation rate. So there's lots of people working on that to figure out what's the star formation rate in different environments, in different galaxies, in different clouds we observe in our Milky Way, and try to figure out what's the correct way to count star formation, or try to even understand the star formation in detail like I do. And so the next two factor is actually hugely being improved by the Kepler spacecraft that is try to characterize the fraction of stars that actually have planets, because Kepler detects so many planets, so they can figure out what's the statistic of finding planets around certain stars. And then we can use the information to improve our knowledge on planet formation to figure out what's the chance you have the planets form at a certain location that might be suitable for life, like in habitable zone. But the definition of habitable zone, there might be like 10 of them, or even like more than, it's countless. Like, so everyone can come up with some idea of try to characterize what do you mean by this planet is suitable for life.
Okay, one last question down in front.
When they're discussing and trying to quantify life, is that specifically focused on what we view as organic, carbon-based? We're talking about civilizations that exist so much beyond our technology. Couldn't we very well be expecting artificial intelligence?
Oh, good question. So the question is about when we say life here, do we restrict ourselves as human life, like carbon-based life, or do we include other forms of life, or even artificial intelligence? So, well, I think when we view these kind of issues, we shouldn't restrict ourselves into a carbon-based life, because based on what we found already on Earth, there's some other species, they don't need light to survive, they don't need to consume oxygen to survive, and that's actually one branch of astrobiology that people actually search for those species live in extreme conditions. And but as for artificial intelligence, I haven't think about that problem yet, but I think it will be interesting to think about that and to figure out whether they could affect our estimates here.
Well, there's, for instance, Kepler's focusing on, when we get to the point of whether it's Kepler or James Webb, being able to detect elements in atmospheres.
Oh yeah.
These little detectors go, oh, this has an atmosphere.
Yeah, so that's one of caveat here. When we say, oh, these planets have very toxic atmosphere, so there's no chance it can support life. But what we actually mean life here, maybe there's a yeah, they can support us for sure, but maybe other kind of life you can support them.
So I believe the term is called Earth chauvinism.
Okay.
Yeah. Okay, but let's thank Star Maker again.